Do you know how scientists can forecast a volcanic eruption? Volcanoes are all around us, and many people live near them. Understanding how volcanoes work and eventually forecasting their eruptions is crucial for keeping us safe. After an eruption, dangers like thick ash, fast-moving lava, destructive mudflows, and toxic gases can spread across great distance. The good news is, scientists can spot early warning signs by monitoring several key warning signs, giving people time to evacuate and stay safe. In January 2006, a series of explosive eruptions from Alaska's Augustine volcano sent ash plumes as high as 45,000 feet, which is about 33 times the height of a Hong Kong's IFC tower. It disrupted air traffic and deposited ash 70 miles away. A 2022 study published in the journal Earth and Planetary Science Letters, titled Modeling Deformation, Seismicity, and the Thermal Anomalies Driven by Degassing during the 2005 to 2006 pre-eruptive unrest of Augustine Volcano, Alaska, was led by Professor Zhan Yan and their team. The pressure was built up within the Augustine 3 months before the eruption. So, how do scientists detect such pressure build-up? Let's use an instant pot model to explain such pressure build-up. Here is an instant pot with a lid and a pressure valve, like a volcano's conduit. Inside, there is magma like the soup. When the heat boils the soup, some volatiles in the magma turn into gas. If the pressure valve is open, the hot gas can reach the surface, generating observable surface heating, which can be detected as increased ground temperature. Then, if the pressure valve is closed, the hot gas has nowhere to go and stays in the hot pot to build up the pressure. So, the lid might even bulge. Scientists can use satellites to see this kind of bulge from a volcano. Meanwhile, the pot may start to break due to high pressure, which generates earthquakes before the eruption. If the pressure rises too high, the valve pops off, releasing everything. Let's see a volcano model. Temperatures here are extremely high that rock melts, and gases dissolve into the magma, building up tremendous energy. As this magma begins to rise through a narrow tunnel called the conduit, the pressure starts to change. Minerals within it can crystallize, partially congling the pathway. The pressure inside the mountain builds and builds. The ground itself can uplift as the magma chamber fills, pushing the land from below. Small earthquakes are triggered by walls breaking under stress, and surface temperatures often rise due to escaping heat and gas. With a catastrophic release, the volcano erupts. All in all, by paying attention to the warning signs a volcano gives off, such as rising surface temperature, ground deformation, and the occurrence of small earthquakes, scientists can forecast an eruption. I hope this video sparks your curiosity about volcanoes. See you!